Hey everyone, in today's video I will be solving another problem from LeetCode. It's today's daily problem, and I think it's going to be the last one I solve that is easy because I'm kind of just it's becoming more and more tedious gradually. Easy problems are just they're so quick to solve, so I'm getting tired of these and bored somewhat. But this one, like I've sold something extremely similar to this one before, very recently, so it's even easier for me. Maybe I'm memorizing some patterns lately or something like this, or just getting used to the easy problems. But yeah, it's noticeable the similarities. So let's start by reading the task. I won't be reading it fully because it's quite long, but let's see. So we are given an integer array prices. Here it is in the example one. We're also given the money integer. And okay, exactly 2 chocolates I need to buy. That makes sense because of the or whatever. So non-negative leftover money I need to have. Okay, minimize the sum of the prices of the 2 chocolates I buy. All right, return the amount of money left over after buying the 2 chocolates. Considering that the prices need to be minimized. So how do we do it? Well, the first of it, very easy approach here works perfectly fine, and that is finding the two minimum prices using O of n time complexity, and I'm not really sure about the space complexity, but I'm pretty sure it's probably constant. Yeah, supposedly. I'm not very good at this, but yeah, I suppose so. So we're gonna have two variables, smallest and second smallest. And whenever there is something that is not yet defined, I prefer doing it this way, and I guess everyone does that, but well, so this is like you set it to infinity because it's not yet there, like the maximum number possible, right? Not to get any problems with the edge cases and so forth. That's just the way we do it. Now we need to go and just iterate through the prices list. So let's go ahead and do it. Let's say for P and prices, for example. And the second thing we need to do is just build a little like a tiny algorithm that changes the both variables depending on like what number we currently see. And so, whenever we see, let's start with the smallest. When do we change the smallest variable? Well, whenever p is less than the smallest variable, but we don't only change the smallest, but the second smallest as well. So, what I mean is, let's just say if p is less than smallest, then we set, first of all, we don't change the smallest variable because we need to set this one to the current smallest, right? That makes sense. And then we set the smallest variable to the current price. And then also there could be a case where it's not smaller than the smallest one, but it's smaller than the second smallest one. I said the word smallest so many times now. I'm starting to stutter, but okay, whatever. L if p is less than second smallest, I just set second smallest to p, and that's it. Um, Now the only thing left that is left to check if the sum of these variables, and we decrement money by their sum, and we see whether the value is going to be non-negative. If it is non-negative, then we just return it. Otherwise, we return money variable that is initially given. So they say it right here. Let me see. Return money if there is no way for you to buy 2 chocolates without ending up in a debt. Okay. I suppose it could be quite much easier to initialize a variable price that is going to be equal to money minus smallest and then minus second smallest, right? Pretty easy so far. And like so far, I mean, this is the end almost. Now we just need to return price if it is more than 0, more or equal to 0, right? And else we just return money. So our initial money variable. Let's check it out now. Let's see how it works. Okay, return price if price is more or equal to 0, right? Okay, let's run it again. What do we have here? Okay, amazing, good. Let's submit it now, see if it works. All right, I love this. Oh my gosh. Okay, let me just resubmit it. Oh wow. Oh, that is incredible. All right, so I believe this is now proven that my solution is super efficient. This is like my solution. I've not copied anything. If there are similarities, then blame them because this is very original. I promise. Really, I'm serious. This is just my solution. So, thank you for watching once again, and see you in the next video.